A baby Tyrannosaurus rex could outrun its own father. Say that sentence out loud and it sounds like nonsense. The most feared predator in Earth's history, outrun by its own child? But that's not speculation. That's what the fossils actually show. And it's just the first thing about a baby T-Rex's life that's going to break everything you thought you knew about this animal. Here's the real question hiding underneath all of it. If a baby T-Rex wasn't a smaller version of the monster we picture, if it was almost a completely different animal, then what was it actually doing all day? What did it hunt? What was it afraid of? And here's the part that should really unsettle you. Was one of the biggest threats to its life another T-Rex? Stick around, because by the end of this, you'll never look at a T-Rex skeleton the same way again. Most people, if they picture a baby T-Rex at all, picture a miniature version of the adult. Smaller teeth. Smaller claws. Same slow, lumbering, tail-dragging monster, just scaled down. It's an easy assumption, because that's how we usually picture baby animals, a shrunken copy of the parent, waiting to grow into itself. For decades, that assumption went mostly unchallenged, because juvenile T-Rex fossils were rare, and the ones that existed were often mistaken for entirely different, smaller species. There simply wasn't enough evidence to argue otherwise. Then paleontologists found juveniles that changed the picture completely. Fossils of young tyrannosaurs, long-legged, lightly built, clearly still growing, revealed something almost nobody expected. A baby T-Rex wasn't a slow, scaled-down killer in training. It was fast. Genuinely fast, built more like a greyhound than a bulldozer, with proportionally longer legs than its adult self would ever have again. Some estimates suggest young tyrannosaurs could outrun their own parents. That single fact should already be rearranging what you thought you knew. Because it means a baby T-Rex wasn't living the same life as an adult, just smaller. It was living an entirely different life, a life built around speed, agility, and constant vulnerability, in a world where the very same species it belonged to could, in some cases, be the thing hunting it. Here's where the picture gets genuinely strange. Adult T-Rexes were built for one kind of hunting, overwhelming force. A bite that could pulverize bone. A body mass that turned every collision into a foregone conclusion. But juveniles didn't have any of that yet. Their skulls were thinner. Their bite force was a fraction of what it would become. Their teeth, instead of being the thick, bone-crushing implements adults carried, were narrower, blade-like, closer to the teeth of smaller, faster predators built for slicing rather than crushing. Which means a young T-Rex almost certainly wasn't hunting the way its parents did. It couldn't. Its whole body was built for something else entirely. Chasing down smaller, quicker prey, darting through underbrush an adult could never fit through, relying on speed and precision instead of raw power. Picture it. Not the roaring, earth-shaking monster from the movies. A lean, feather-fuzzed juvenile, barely reaching an adult human's hip, sprinting low to the ground through Cretaceous underbrush, chasing something small and fast. A lizard, an early mammal, anything it could catch before it vanished into the undergrowth. This is an animal running for its next meal in a completely different register than the one it would eventually inherit. Fast, light, opportunistic. A totally different hunting career, packed into the same body that would, years later, become one of the most powerful bite mechanisms evolution ever produced. And here's the detail that makes this even stranger. Some researchers now believe juvenile and adult tyrannosaurs may have occupied different ecological niches entirely, effectively acting like two different species sharing the same ecosystem, simply because they were built to hunt completely different things. Small, fast prey for the juveniles. Massive, armored herbivores for the full-grown adults. Which raises an uncomfortable question nobody likes to sit with for long. If juveniles and adults weren't competing for the same food, what happened when they crossed paths? There's a story buried in the fossil record that makes this question impossible to ignore. In certain tyrannosaur nesting and habitat sites, paleontologists have found something unsettling. Juvenile tyrannosaur bones bearing bite marks that match the tooth spacing of adult tyrannosaurs. Not from a different predator. From their own kind. We don't know, in any specific case, whether this represents a parent accidentally injuring a straying juvenile, competition between unrelated individuals, or something colder. Opportunistic predation on a smaller, vulnerable member of the same species. But the evidence exists. It's not folklore. It's tooth-marked bone. Sit with that for a moment. One of the greatest dangers a baby T-Rex may have faced wasn't a rival predator, or a defensive herbivore twice its size. It may have been an adult of its own species, bigger, hungrier, unbothered by kinship in the way we instinctively assume parental animals should be. This is where the story stops being simply biological and starts becoming something closer to unsettling. We like to imagine parenting, even in ancient animals, as something warm and protective by default, a built-in instinct that guarantees safety. But nature rarely guarantees anything. If juvenile and adult tyrannosaurs really did compete, however rarely, for overlapping resources, then survival for a young T-Rex may have depended on one skill above all others, staying out of the way of animals that looked exactly like the one it would eventually become. Growing up, for a baby T-Rex, may have partly meant learning to avoid its own future. Let's slow down here, because there's a softer side to this story too, one that complicates the picture in an entirely different direction. Not every piece of evidence points toward danger and competition. Some tyrannosaur nesting sites show patterns consistent with extended parental care, adults returning to the same territory repeatedly. Juveniles found in proximity to adult remains in ways that suggest social tolerance, not just conflict. Some researchers argue that young tyrannosaurs may have stayed within a loosely protected family range for a period after hatching, benefiting from an adult's presence nearby, even if that adult wasn't directly feeding or guarding them the way a modern bird might. Which means the honest answer here isn't simple predation, and it isn't simple nurturing either. It's something messier and more realistic. A young T-Rex may have lived somewhere in between, tolerated, sometimes protected by proximity to a territorial adult, but never entirely safe, and eventually facing a version of independence far earlier and far more brutal than almost any parenting story we tell about modern animals. Here's the twist that reframes everything we've covered so far. We've been imagining a baby T-Rex's danger as coming primarily from outside its own species, rival predators, defensive prey, environmental hazards. But the deeper you look into tyrannosaur biology, the more it becomes clear that some of the greatest risk a juvenile faced may have come from simply existing at the wrong age, in the wrong place, near an adult of its own kind that didn't recognize or didn't care that they shared a lineage. This isn't unique to tyrannosaurs. Modern crocodilians, among the closest living analogues we have to ancient archosaur behavior, sometimes prey on their own young under the right conditions. Territorial disputes. Food scarcity. Mistaken identity in murky water. It happens. And crocodilians, like tyrannosaurs, are ancient, deeply instinct-driven animals operating on cost-benefit calculations we'd find uncomfortably cold if we saw them play out in real time. Which brings us to the deeper question hiding underneath all of this. What did a young T-Rex actually understand about its own world? Not human-style understanding. Not language, not abstract reasoning. But something more basic: pattern recognition. Threat assessment. The ability to tell, at a glance, whether a shape moving through the undergrowth was safe to approach or something to flee from immediately. We know tyrannosaurs, based on their brain structure, likely had excellent vision, strong spatial memory, and keen senses tied closely to hunting. A juvenile navigating a world full of larger, more dangerous versions of animals it might one day become would have needed exactly that kind of fast, instinctive threat recognition to survive its first year at all. Carrying that kind of vigilance every single day wasn't fear in the human sense, nothing so complex as anxiety or dread, but a constant, wired-in alertness. Every rustle in the ferns a potential threat. Every shadow crossing the clearing a decision point. Run, freeze, or investigate. A nervous system built entirely around not becoming someone else's meal, in a world that included creatures who would, decades later, share its own exact skull shape. There's something almost unbearably poignant in that image, if you let yourself sit with it. A creature spending its earliest, most vulnerable months learning to read danger in a landscape partly populated by scaled-up versions of its future self, animals it might have unconsciously recognized as kin, and yet still had every biological reason to avoid. This is where the story stops being just about dinosaurs. Because the tension a baby T-Rex may have lived inside, belonging to a species while still needing protection from members of that very species, isn't some ancient, alien situation confined to the Cretaceous. It echoes something almost universal across the animal kingdom, including, in more complicated and mediated ways, in us. Growing up anywhere means learning, gradually and sometimes painfully, which parts of your own world are safe, and which parts merely look familiar. A baby T-Rex didn't have culture, language, or memory the way we understand those things. But it had a body built for one kind of life that would eventually be replaced by a body built for another, entirely different one. Speed traded for power, agility traded for mass, vulnerability traded, slowly and unevenly, for dominance. Somewhere in that transformation, an animal that spent its first year running from danger became, eventually, the very thing other animals spent their lives running from. We don't know if there was ever a moment a juvenile tyrannosaur sensed that shift happening inside its own body. We don't know if instinct alone was enough to guide it, or if something closer to learning, closer to accumulated experience, shaped how it moved through a dangerous world day after day. The fossil record can only show us bones, growth rates, bite marks, and inferred behavior. It can't show us what it felt like to be small in a world engineered, eventually, to make you enormous. But maybe that gap is the most interesting part of the story. Because every creature that has ever existed, including us, has spent some portion of its life being smaller, faster, and far more vulnerable than it would eventually become, learning, one encounter at a time, which shapes in the underbrush were safe, and which ones, however familiar they looked, were not. So the next time you picture a Tyrannosaurus rex, teeth bared, ground shaking, utterly without fear, remember that every single one of them started somewhere else entirely. Small, fast, constantly alert, running through ferns twice its height, watching shapes move in the distance, trying to tell the difference between something safe and something wearing, however distantly, its own future face. And if the most fearsome predator in Earth's history spent its earliest days simply trying not to be eaten, what does that tell us about what it actually means to grow into whatever we eventually become?